Good morning, everybody. So, well, it's said a problem shared is a problem halved. So I'm very interested to hear from you if you think that some of these challenges are somewhere you can help us with. Blue Wireless is an interesting company, and I'll talk more about Blue Wireless in my slot later this morning. But we're a bit different from most companies, I think, and as a result of that, so are some of the challenges that we face in verification. So if you find some of these interesting, then please let us know. This is one of our first challenges here. The way that we do our design is that we are a SystemC design, and we use C to silicon. So unlike a conventional or more conventional system, we don't have that C model to compare our RTL against. Any self-checking verification system needs to have a reference, and in our case, that isn't necessarily available to us. For us, what would be the model, i.e. our C model, is actually our implementation. So we have it in SystemC, and we use C to silicon to turn that into the RTL. And the only other models that we have available to us are in Matlab, and they are too abstract and high level for us to use for what we do. So to support our verification, one of the things that we have to do is we have to have a partial model of our system embedded within our test bench. And in some cases, that is actual C code running on an embedded processor in the system to provide that stimulus and response and checking. And so from that aspect of the verification, that means that our verification effort, in that domain at least, is higher than it would be ordinarily. But what we've saved is having the two separate models and the investment in the C model and the RTL up front. So that's certainly been interesting. The second challenge that we have is a lot of our framework is automatically generated. So the IP blocks that we develop are parameterized in the SystemC, and that gives us a great deal of flexibility in putting systems together and also running what-if scenarios. What if we have an extra 8 bits on this bus, or what if we have an extra set of registers here, or a number of different ports? So we can play very flexibly with the IP blocks that we have. But that means that we have our own framework for specifying this stuff. So if we have third-party IP that we get in from anywhere else, quite often that comes in as RTL. It's not SystemC. And it's difficult for us to then pull all of that together and run simulations or checks, because half of our world is in SystemC and half of our world is in RTL. And really, to pull that together, you need everything in the same camp. So what can we do? Well, one thing we can do is we can verilate. So we can take the RTL and we can try and go back to SystemC. That doesn't work very well because it's an automated process, and it's quite difficult to debug because you lose information, meta information, as you go between the two states. And similarly, if we go the other way, we take everything to RTL, it's very difficult to debug the SystemC side that we've written for our own IP blocks. So that certainly has been a very big challenge for us to put that together. And of course, the whole thing is constrained by licenses. Certainly, C to silicon is not a particularly cheap route. And our third challenge really comes down to us using SystemC rather than System Verilog. So we have a very high-level implementation that we work with. Having chosen C2S as our flow, SystemC is the obvious target for us to do verification. It's quite cutting edge in its thinking, and in some ways there's fewer trained engineers. And by that what I mean is, SystemC is, at the end of the day, it's C. But a lot of engineers are used to working in RTL and RTL verification. So if you take pure verification, it's a slightly different mode. We found that the UVM and coverage testing coded by TVS, and I'll talk more about this again this afternoon, it is a viable alternative to System Verilog, and it's certainly worked quite flexibly for us. And we've also done a lot of work with Crave, which I think some of you will be familiar with, for constrained random testing. And And coupled with that and our automated framework of generation for blocks, the effort that we spend now, it's on the scoreboard, the checker, it's in the verification bench, and then we refine that for the missing coverage that we don't have from the results. So we target the last piece. And we've been able to integrate all of this from the very top, so the whole C2S generation down, into regression suites, and we're using tools like Jenkins. If any of you are familiar with Jenkins, it is a system for automated test and test management, allows us to generate a complete system, run through the whole regression automatically and control that in parameterized ways. So again, in terms of the what-if type scenarios, we can run some very complicated what-if scenarios right from IP design and block through integration, through regression test, and through to the result. So it's been a very powerful and flexible system for us.
Thanks, Andy. Thank you very much. Any questions? I know Blue Wires have got quite a unique design for verification work, so there might be some interest in that.
Andy, do you have to worry about verifying the correctness of the C2S flow, or do you assume that's okay?
Good question.
So the question was, do we worry about verifying the correctness of the C2S flow? And the answer is yes, we do. Particularly as you would with any tool that you're using, we're always cautious, particularly when we get new releases of the tool. We look at the output from the previous release and we look at the output from the new release, and we compare the two. And we check that the tool is not doing anything untoward with our design from what we'd expect. And we have verilated to go back, but the trouble with verilating is it's another transformation step, and if you've got problems in that flow, you're never quite sure who's introducing the problem. So it's not trivial, but it is something that we do worry about, yes.
So just to follow up on that, maybe on previously, is there any equivalence checking? So I don't know, one skill working the other EV about a SystemC to Verilog or Grego equivalence checking. So you looked into that?
Sorry. So the question was, do we do any equivalence level checking? Yes. And the answer is yes, we do equivalence level checking. Automated. As far as we can, yes. It's not an easy process to automate, not least because of the output. It needs a lot of interpretation of the output to be sure that you've got equivalence.
But I guess it'd be interesting for people, because this is, not many people design this system. So you're seeing it as an effective design flow, but not just for verification, but Nick mentioned PPA.
Yeah, we do see it as an effective design flow, and that's what I'll be talking about later this morning.
People can't wait. I just got to look.
Sorry, I don't think this is a very question, but given all these complexities, what is the big benefit you see for doing SystemC in the first place? Is it a design simplicity or a logical simplicity or a power area advantage?
So the question was, given the complexities that we have using SystemC, what is driving us to take this approach? And I think that the answer will be given later this morning, but fundamentally, Blue Wireless started as a very small company. It was very constrained in resource, like many startup companies are, and it was very constrained by cash. And so we needed a flow for us which was cheap to run, didn't require a large amount of EDA investment up front, and could be run by a skeleton staff of people. I'd say the other key pillar that we have from this is the flexibility of our IP with the auto-generation framework that we have gives us a real rapid advantage in exploring what-if scenarios.
So if you haven't heard enough hints to listen to Andy later, then I'm not sure how many you can give it. Anyway, thanks very much for Andy. Thank you.
Okay.